All right, well, thank you everyone for joining us today for this talk on security monitoring of OpenSearch with OpenSearch, which we've been eager to tell you about for some time now.
Thank you very much. So my name is Nils Bandener. I'm a freelance software architect and consulting and working with Eliatra, which I think you have already seen in this conference. And we are quite invested in the OpenSearch security plugin. I'm a co-maintainer of that repository.
And hi, everyone. I'm Craig Perkins with AWS. I'm also one of the co-maintainers of the security plugin and have been working with Nils for some time now. I'm also a maintainer on a few other of the components of the OpenSearch project, including the OpenSearch core.
Yeah. Let's go to the OpenSearch security plugin, and actually it's your turn.
So just a little bit of an overview about the OpenSearch security plugin. This is the security layer of OpenSearch and where you get fine-grained security controls. This is the plugin that gives you encryption, audit logging, access control, and authentication. And not to be confused with security analytics plugin, which I've actually received a few of at this conference already as well.
Yeah. So we both are maintainers of the secret plugin, so we know quite a bit about this feature. We know its strengths, but also about the challenges that it could be present to administrators. And unfortunately, there are quite a few. It's been worked on, but at the moment, there are some challenges. Just a few to look at. Very simple one is very common one is just making authentication safe. So being safe of any attacks, brute force attacks, whatever. Another one, completely different, is for administrators finding the right privileges for users. Someone complains, I don't have the right privilege, something doesn't work. How to address this? And also, again, something completely different, making configuration updates safe. And the goal of this presentation is kind of to combine our knowledge of the security plugin with the OpenSearch ecosystem, which can be relatively diverse. So we have quite a few components, and at least I do not so many of these. So I'm quite focused on the single area. And so for us, it's also kind of an experiment to see how we can combine our existing knowledge of the security plugin with this vast offering about the OpenSearch ecosystem.
And so what do we want to achieve today? Well, by the end of today's talk, we want to leave you with some helpful solutions that you can bring back to solve real administrative challenges that you may face as cluster administrators. We'll talk a little bit about, as Nils had mentioned, those different components in the OpenSearch ecosystem, their roles, strengths, and weaknesses that we've encountered. And then we're going to learn some secrets about OpenSearch, in particular with the security plugin. I say secrets, but maybe some lesser-known features out there that can really help you. And we're going to learn about the observability of OpenSearch with itself. We're using our own software as builders to solve real problems that customers face.
Yes, let's have a quick overview what's going to be coming up in the next minutes. So we're looking at 3 use cases, which kind of mirror what I've already said: authentication monitoring, user privilege monitoring, and configuration change monitoring. Interestingly, also we're scaling up the complexity of the solution. So we're starting very simple and going more complex.
And at the end, we're going to have a demo and live Q&A, whether it's questions about the presentation or questions during the live demo. So please feel free to interact at the end.
Also, we really didn't decide what to demo, so we are kind of dependent on you asking questions and requesting things to be demonstrated, if we can. So let's jump right into the first use case, authentication monitoring. As I said, it's very simple. Let's monitor our OpenSearch cluster for failed logins.
And to do this, we're going to use a feature of the security plugin known as audit logging. So OpenSearch provides a number of different log types some of which are just the application logs themselves, other of which are the audit logs, and the audit logs in particular are around security and compliance for the cluster. So it tracks individual events that transpire in the cluster. Anything from when the request is authenticated to when the request is authorized, and a couple other audit log categories that we're going to be highlighting in a little bit.
Yes, let's have a look at the monitoring architecture. We will look at such architectures also later, again and again. So this is kind of the most simple architecture we have. So we have a main cluster, which is supposed to be monitored. We have the monitoring cluster, which takes the monitoring information. For the audit logging, would be theoretically also possible just to save monitoring information on the main cluster, but for many reasons like availability, etc., this is of course not the best solution. So we're having two clusters, and on the monitoring cluster we can use then diverse applications like dashboards, visualizations like alerting to process the logged data.
And then Nils mentioned we're using an external OpenSearch cluster as the audit log sync. The audit log is very configurable. One of the static configurations is where to log it. And what you're looking at here is some of the static configuration, which would be the destination cluster, if you want to configure any particular index it would log to, and then other information it needs, such as the username and password when posting to that external cluster. There are other syncs out there, such as Kafka, Log4j, internal OpenSearch cluster. It's a very configurable component. But in this demonstration, we're using a separate monitoring cluster to store the audit log information. And this is just an example of what an audit log document may look like that's stored within the cluster. And this is broken down into categories. So you'll see different metadata associated with the different categories. I want to point out that there's some useful metadata here for our use case, this being failed login. We will receive information about the caller. In this case, we do know metadata such as the IP address, and down there you might also see that it's originating from OpenSearch dashboards, as well as a username who might be originating the request from as well.
Yeah, one thing because before we look at the actual application, that just should be mentioned just as a good hint. When you use the audit logging feature, by default, the data will be just logged out with the default mapping, which might be sometimes not the most suitable default mapping. So as a recommendation, before you use the audit logging feature in an OpenSearch cluster, create an index template to get some right mappings for certain attributes, in especially keyword mappings, because otherwise, for example, in OpenSearch alerting, it would be sometimes not possible to use the respective attributes. But yeah, let's have a look at the application itself.
All right. And just for our first use case, oh, sorry, that's scrolling a little bit quick. This is about setting up a bucket monitor in the OpenSearch alerting plugin in order to send an alert for when the number of failed logins exceeds a certain threshold. Very basic setup for monitoring to build up to our next use cases. But one other helpful feature in here is you could also further drill it down by username too to know who in the cluster might be failing or struggling to log in as well. Now, in here, you can configure a notification channel to send notifications to as well. That's configurable with different destinations.
Here we have the webbook.
All right.
OK, so this was already the very fast first use case. As we said, we can have a closer look later in the demo. Second use case, user privilege monitoring. As we said, the scenario is someone is administrating, for example, a cluster running dashboards, and a user wants to use a particular feature, but they just get a pop-out, forbidden, whatever, and what to do then. And we are looking again at the audit logging for this.
And so this is another document. Well, this is another category at this point in time. And you'll notice here the category is missing privileges. So in this event would be trigger when a request is authenticated, but the user fails to have the necessary permissions to perform the requested action. So you'll notice the metadata is a little bit different in this category of information. In particular, I want to point out that we do have the action information, the action that the user is trying to perform in here, this being a bulk shard write request. And since a bulk shard write request occurs on a set of indices, we also have the set of indices that the action is being performed on as well, contained in this document.
Yes. However, if you're administrating a cluster, you might actually also have seen other logs. So by default, many people are maybe even not aware of the audit logging. So there are also the standard log files, like every standard web application has. And there are also log entries about missing privileges, and they look quite different. Here's an example for that. And yeah, they are, to a certain extent, they have a different approach to logging this data. It's quite interesting that here in the lower half, we see kind of a matrix, which shows that we have two dimensions of missing privileges. We have the dimension of actions like indices data write bulk chart or indices data write index, which are both actions which map to privileges. And on the other axis, we have two different index names, test A1 and test B1 in this case. And in this matrix, we can actually see that we already have most of the privileges. So the bulk chart indices, the bulk chart actions have privileges for both indices, as we can see with this by this OK marker. The only missing privilege is indices data write index for test A1, where we see this big missing flag. If we compare this to this log message, we see it's actually in contradiction. What we see here, yes, that's a bug, or you could call this a misfeature. So this information is actually not quite accurate here, but this is more accurate. Of course, this is a bit of a concrete example. It's very rare that we have this situation that's only relevant for bulk requests. Still, we want to make the case. In this case, we have more detailed information in the log files, and we take this as a challenge to pass this information for our application.
And so in here, we're configuring the log4j output format. And what we're going to do in addition to the standard format is add user information here. So after a request is authenticated in security, we do hydrate the log4j context with username. And in here in particular, this logout layout pattern, if you look at the log format of the message, we're doing this again so we could parse it later as well, but we're including the user information with that %x user, which is helpful context. There's other additional context we might want around, say, the opaque ID, which could identify a request or a task ID, but they're not available to us here.
Yes. Oh, that's the result. But let's have a look now, moving forward, at the OpenSearch ecosystem a bit more in detail. So out of this ecosystem, we're now looking at components which can do log processing and log enrichment. Yesterday, we have also learned that log stash might be actually also an option for doing this, but at the moment, we are looking only at these. So these options have different capabilities and inabilities. FluentBit, for example, is it's not directly a member of the OpenSearch ecosystem, but often used. It can read log files just from files on a cluster. It can, however, also listen to REST endpoints for log events. It can do custom processing, which is interesting for us, for example, using Lua scripts or also regular expressions. It can internal event routing, so complex log processing, and it can break one event up into several. However, we don't have a state across events, which would be useful for aggregations. But yeah, it's already, for our case, quite useful. On the other hand, Data Prepper, it can't read from log files. So if we use Data Prepper, you always have to, if we have log files, we have to use another component like FluentBit to push the data there. However, it has a global state, at least it can manage a global state and can do aggregations. Just for completeness' sake, we have also the ingestion pipelines in OpenSearch, which, however, can only operate on single documents. That's why we won't look at these now, because it's not what we need at the moment.
And so here's a brief reminder in the previous use case on authentication monitoring of what the setup looked like with one cluster and another cluster with the audit log configuration. But now we're going to be adding FluentBit in here. So audit logs remains, we're sending those to the monitoring cluster, but for the OpenSearch application logs, we're using FluentBit to ship the logs directly to the monitoring cluster. And we use parsers and filters from FluentBit to do the log processing to get those to OpenSearch.
Yeah.
And this is a little bit of the FluentBit configuration. On the top, you have source, sync, source being the application logs from OpenSearch. We have some multi-line parsing, because as you've seen from those missing privileges logs from earlier, some of them might be on multiple lines there. And then you also have the output, which is our monitoring cluster. And here, configured similar to the audit log, you would also need to configure with the user and password as it's posting the data to the monitoring cluster there. And this is what the parsers and filters configuration. So first filter is for the multi-line processing. Second filter is a parser where we had the log4j output format earlier. This is to help us parse it to get that metadata back into structured format from the output log format, which is in plain text. So we're getting the Java class name, we're getting the log level, we're getting the timestamp, we're getting the user, and we're getting the message. And this is the result. So this is the data that we have to work with here for user privilege monitoring. So same ones that are parsed out there. And you can see on the left is the log line corresponding to the missing privileges.
Yeah, so far we did rather standard log processing, chopping apart a log line into very standard elements, but actually we did this stuff to have this missing privilege analysis, and this is stored in this matrix we have been looking at. So we need to do some more. And we have two challenges here. First of all, we need to do the string parsing. We now chose FluentBit from the ecosystem to do that because we need to read from log files anyway. And it has quite powerful string processing capabilities anyway. And the second one is also just data modeling in OpenSearch. So how do we represent this matrix, which we see here in an OpenSearch index? For this data modeling, I don't want to go into details at the moment, just as a quick high-level overview. So the native representation of this matrix could be kind of a nested JSON object, so we have to map everything to JSON. However, in OpenSearch, you likely know that nested objects are kind of a special thing. So there's this mapping type nested, which you have to use when you want to use nested objects and preserve all information inside. However, we tried it and we found out that if we use this mapping type, no luck in dashboards, you can't use that for visualizations. So we went ahead and went back to the drawing board and came to this solution. We now disregard the elements which OK privileges. So we only care about missing privileges, which is enough for a use case. And we have one document per action. So in each document, we have an action with a missing privilege. And additionally, in the same document, we have one or more indices which correspond to that action. And how do we parse this now? So we do this with FluentBit and with the Lua script. I'm not going to say, ask, can you read this? No, I'm pretty sure you can't read this. You're also not supposed to read it. In the end, we will post a link to a GitHub repo where we have all configurations, all scripts inside here, so you can look it up there and review what we've done there.
And now with this data on missing privileges, now we're really trying to get to the insights in all of this. And this is for cluster administrators. So what you're looking at is a dashboard where you can view on the left-hand side, you'll see index permissions, right-hand side cluster permissions. These would be the requests that would have missing privileges. So these could be either users trying to do actions in which they're not supposed to, or on the flip side of that could be more in the principle of least privilege, cluster administrators have very tightly, narrowly configured what users can do, and maybe they're trying to do something legitimate and getting insight into what privileges they're missing that you would need to grant them as you're figuring out how minimally to provision a user.
Yeah, at the top, we also see here the users, which we can use to drill down into the different data just specific to a user. So that kind of means whenever a user comes to an administrator and says, I have a problem, you can see whether that username shows up there and just drill this user down. And also interestingly, in the end, which is also important, missing privileges are not only missing privileges, but it can be also errors in the privilege configuration, which might lead to missing privileges, but are a bit different beast of configuration error. So the user just are lacking the privileges because something under the hood goes wrong. So we also see these log messages here. Yes, final use case already, configuration change monitoring. What is this about? So the security plugin is responsible for two things, authentication, authorization. And both things can be configured dynamically, so you don't have to restart the cluster to change the configuration. There are special APIs then to change the configuration. This is very useful. However, it also bears the risk that because if I post bad configuration, there's actually the chance that I break the cluster. It's not so relevant, but also can happen for authorization for roles. Most important is the authentication configuration. Yeah, if I break authentication, of course, no one can come into the cluster. So that's why we want to monitor configuration changes.
And back to the audit log, this time a different category though. And this is part of what's called the compliance audit logging feature in the security plugin. You'll notice the category here is compliance internal config right. And what we're doing here is listening for changes in the security index. And I know I personally find this particularly helpful because it provides contextual information about what had changed and when. So this is important to know if there's a change in a role definition, if there's a change in role mappings. You can get those here and only the diffs. And so you'll see there, we do have the diff content as well, that audit compliance diff content. This is on the security index. It's important to know that this feature allows you to track changes in any document in any index, but this is particularly useful in the security plugin. So you can tie at this timestamp, this is exactly what had changed.
Actually, what's quite useful about this, so we haven't created a demo for that, but just as a hint. So what the security plugin is usually lacking is kind of a history of configuration changes, but this exactly gives you that history. So it's either in an index, or you could even set up an alert which sends you a nice email which informs you about a configuration change. But our use case here is to look for errors which occur directly after configuration updates, because errors which occur directly after configuration updates are maybe likely they have something to do with that, and that's why we're interested in it. This is an example for such an error log, and the example itself is not so relevant. What's relevant here is it's a different log file. So we have the audit log in our current configuration, which we have been talking about, posted by the audit logging feature directly to an OpenSearch index. This is by default written to a file on the cluster, which is for now completely independent. And yeah, what shall we do about this? So we have two challenges here. So we have log events from two different files, and we now somehow have to process these together, and we need to do the correlation by time. And let's have a look how we achieve this.
And for this, I'll give you a little hint. We're going to use Data Prepper here because of its advantage there in keeping state across events and letting us aggregate several events into one.
Yes.
And also, I'd like to mention here too, we've took advantage of writing a plugin in Data Prepper as well to do some of the correlation from the configuration change in security to any errors afterwards, to keeping track of the last configuration that occurred before the error.
Right.
And just a reminder of the architecture from the second example here. The audit logging was going directly to the monitoring cluster, and we used FluentBit for the application logs. If we go ahead now, though, we're adding Data Prepper in here. One thing you'll notice, we're not writing the audit log to the monitoring cluster now. Now, instead of writing it there, we're changing the sync and putting those into the application logs using a log4j sync, so they're interleaved in there. There's a little bit of change in the FluentBit configuration that needs to happen because that's output in a JSON format. All of the code is provided to you at the end on the slide, and we can go into that later if you'd like. But what I'd like to mention here, FluentBit's now going to send it off to Data Prepper where we can do that event correlation. And at one point, we did try connecting the audit log to Data Prepper because Audit Logs supports webhook as a sync, but it's a fire hose, and it sends events one at a time, and Data Prepper expects them to be batched. And so it's not directly connectable at that point. So we took a bridge there through the application logs.
Yes. We mentioned already this Data Prepper custom plugin. So the cool thing about Data Prepper is it supports the pluggable architecture, and plugins can be relatively easily installed into it. Even if you deploy Data Prepper via Kubernetes, it's still very easy. So here is just a section of our plugin. Again, the full source code will be in the repository you will find at the end of this presentation. In the top line, we see here an annotation which gives the plugin a name. So here it's log event time correlation. There's a bit of boilerplate. Interesting is in the lines 26 and 27, the two private volatile variables, which kind of are the state which spans several events, several log events. We can save here state which we want to use for later processing of log events. And the second one, group start event, is kind of, in our case, the log entry in the audit log, which indicates the configuration change. And the first entry is the group ends at. It's a kind of timestamp in milliseconds since epoch, which we also calculate when the group starts. And it indicates when we want to stop looking for further log events which might be correlated to the first one. And now let's look at the actual code. So that's the do execute method, which just expects a collection of log events and loops through these and can just modify these. And interesting is in line 44, this if is start event. So here we check whether this log event is the audit log event for the changed configuration. We calculate the time when we want to have the group ended. So we can configure the time in the configuration, as you can see, how many milliseconds the correlation should go on. I think by default we're using 5 seconds. And we just also remember the group start event and modify this event also to mark it as the start of such a change. And in the block below, from line 49, we kind of just modify, we check if the events are within this time window, and if so, we just modify them and put a back reference to the start event.
And this is what our Data Prepper configuration looks like. So on the top, you have source. On the bottom, you have sync. And in the middle is you have the configuration of this processor that we had built here. So source, again, was in here we're using FluentBit to post to an endpoint, which Data Prepper is listening to logs at, log ingest. And on the sync there is the monitoring cluster, same as configuration of what you had seen previously. And here in our log processor, what we're really looking for is that compliance internal config right, because that's the key to look for when the security configuration had changed. And what we're trying to correlate any events that occur after the event with that particular event when the configuration had changed.
Yes, and this is how the result looks like. So you have to actually read it from the bottom to the top. At the bottom, you have this audit log event, compliance internal config right, as you can see in line 21. And it has this UUID, which we have been setting in the plugin in line 27. And above, you have this error log, which in lines 12 and 13 has the forward references to this audit log event. And these data can be already used to make aggregations, to make alerts just based on this information. Just as a side note, in hindsight, we concluded it would have been better to drive the denormalization a bit further, so we're using back and forth references, which also not really easy to process in OpenSearch. So sometimes we should also do more denormalization, so just copy more data from the head. But this is the result.
Yeah, and what we really wanted to hear is drive insights for cluster administrators to see if any particular change had caused a noticeable effect in the cluster. What you're looking at here on the top left is the timestamp of the previous configuration change, and bottom right is also on the vertical bars on the left-hand side would correspond to changes in configuration. And the red ones, I don't know if that shows up well there, but that would show spikes and errors. And that could be anything from syntax issues to also when using advanced security features, there could also be some syntactical errors in there. And you'll see down below some actual examples of the error messages themselves. And I don't know if you'd like to elaborate any further on that, Nils, with the message.
Yes, we're already done, mostly. So let's wrap it up. So what was our experience?
Well, in going through setting up OpenSearch with a monitoring cluster and the various different configurations that were used, we had experienced a number of issues encountered during setup. At first, we tried using the Kubernetes operator and ran into an issue trying to set up a different audit log sync than the internal OpenSearch log. And that's just one of a couple of issues that we've encountered setting things up. So it was, as software builders, I think one thing that's important for any software builder to do is use the software and dogfood the software that's built, go through the user's experience, because you never know what it's like on the other end from being the software builder. You might be an expert, but somebody might be coming to your product for the first time, and it's important to have that deep level of empathy.
Yeah, just as an illustration, so I kind of estimated we can do this application in 3 days. In the end, it was 2 weeks. It was lots of trying, backing up again, next option, also that failed, etc., etc. So yeah, it was an interesting experience. I've learned a lot. So I think the next application won't take as long then. But yeah.
Yeah, in many of the instances, if we did encounter an issue during setup, we had either raised our hands on GitHub and say, either file an issue if one didn't exist. If one did exist, then we would say, hey, I've encountered this too. Any pointers, any workarounds? And in some instances, we decide to be proactive and deep dive and proactively contribute back so that anybody else does not encounter the same.
Yes. And we're nearly done. So here you can see a link to that repository. So it's still a fluent work in progress. We did our best to make it accessible, but certainly there's lots of things to be improved. So have a look and tell us what you think. And now it's kind of the time for you to ask questions, or if you want to see something in action, even to ask for it, because otherwise we wouldn't know what to do.
Raise your hand.
Thanks. So I'm very glad you went through this exercise because I did the same. I had similar issues like you. Have you considered because much of your work, or at least part of it, can be integrated as part of the default distribution. For example, the index template for the audit logs, why not being already pre-created on the cluster if I enable the feature, or the user attribute should be by default on the log4j template. So have you considered kind of fixing this stuff also on the default distribution?
That's a good question, I believe. So the challenge is here a bit, you can configure audit logs to kind of be written in any index, and you kind of have to decide when you create an index template for which index it shall exist, right? So it's half a documentation issue and maybe also half an infrastructure issue. So for sure, we should, I think, just provide this mapping in some file. I'm not sure where, to be honest, but somewhere. And also for cases where, however, we wouldn't recommend this, where you log it on the local cluster, yeah, then this you could already create this template by default, yes.
Yeah, and I would say for me that issue is actually unbeknownst ahead of time and one of the ones encountered in this process.
I have a very detailed question. So in the beginning you said that the missing privileges in the audit log and the missing privileges in the standard log, they differ. And you said there was a bug or an issue, so I didn't understand. Could you explain that?
Well, the audit log said the missing privileges was this index write bulk chart, or similar. But that wasn't actually the issue. The issue was this index. Let's look at the slide.
Index data, right?
So it, it isn't it? Yes. So here we see requested privilege indices data write bulk.
Aaron, could you please put the slide up?
Oh, yeah. Indices data write bulk chart. That's what was requested. Or that's what the audit log said in line 10. And here we see in line 7 that missing was actually indices data write index.
So that means it's a bug.
It's wrong. The bug is always in reference to a specification, so we have to revisit the specification.
Right. Okay, thanks.
So the relative complex setup here with using both the Data Prepper and FluentBit, isn't it more actually a problem with the logging that you're actually missing audit logging in the core products, which should log the relevant stuff, and then you would not have to have this complex setup and trying to have a state and correlate and these things?
Right. So to a certain extent it is an issue, but also the goal of OpenSearch and all other software for observability is also kind of to support software which is less than perfect, which is not as observable as it might be. So it was kind of just a very realistic scenario, I believe.
Time for one more quick question. All right, well, let's thank our presenters. Thank you so much. And